Hello guys, this is the talk about your jump into data science, and I'm Yuri Koshnitsky, also known as Yorko, so the leader of mlcourse.ai, open machine learning course. So actually the main motivation for all this discussion was the next steps in your career when basically ML, so some basic ML is covered. So what would be your next steps to actually get your first data science job? If you're not there yet in the field. So just a bit about myself. I've got my bachelor degree from MIT. It's Moscow Institute of Physics and Technology, so it's Russia. It was applied physics, namely aviation. So then I did masters there as well. So I switched mostly to coding and applied math. Then at the same time worked as a business analyst and business intelligence developer, but then switched to academia to pursue a PhD degree from Higher School of Economics. So it was about applied math. Then actually my first data science position was at Mail.ru Group. So it's a large IT giant in Russia. So if you probably know Yandex, it's the biggest Google competitor in Russia. Then Mail.ru Group would be the biggest Yandex competitor in many domains in Russia. And so at the same time, I started leading mlcourse.ai, open machine learning course. And currently, I'm a data scientist and NLP practitioner at KPN in Netherlands. It's a telecom operator. Yes, I'm a bit crazy about my cat. Yeah, there, this bastard is, I can show you. All right, yeah, so hello. There it is, this fat guy. Okay, we'll let him go. Right, okay, so that's enough about me. And let's discuss first who in general are data scientists. So I don't think I need to provide here a right definition, so we can always question the definition of a real data scientist. I would say it's something like a person who improves business processes with insights from data. But of course, we can challenge this definition. So what's the precise difference with data analysts then? So here I will steal a couple of slides from Alex Natokin. So it's the leader of open data science community. So I like the idea of this triangle. So basically data scientists deal with business, so domain knowledge, which is here on top. Then math, including actually everything like statistics, machine learning itself, algorithms, data structures, and so on. And then development side, so what's known as DevOps, development and operations, software engineering, programming. So actually maintaining your product in production. That's also what's typically expected from data science. And so this triangle actually helps to distinguish different flavors of data science. You see, well, if you are a nerd like me, you can see here a Dirichlet distribution. So this triangle can define actually different ways in which everything actually can be called data science. Yeah, so if we look at the left top corner, and here this edge is highlighted between math and developer, that would be something close to ML engineering. So ML engineers know algorithms really well. They are really good at development. Well, maybe they're a bit less good than developers themselves, but still they're good developers. They do a lot of DevOps, maintaining products in production. Well, maybe they're not really close to business, so they're a bit far away from domain knowledge. So typically, regardless of business applications, they still have to do algorithms and actually programming and actually support other folks with deployment. Data analyst would likely be a person in between this math corner and domain knowledge. So typically this guy talks to business, knows where data exists, which data is relevant for business processes. So data analysts might work with, let's say, with Excel, preferably, So maybe data analyst doesn't need to write code at all, though now I would say more and more data analysts actually know Python and write code, but at least that's not required. At least this corner about development, so it's not required from data analysts. So data analysts typically know machine learning, so they can build predictive models, but it's here on the edge between this modeling and domain knowledge. A data engineer would highlight this edge between domain knowledge and development. So typically, data engineer helps in organizing data. So he would know, so he or she would know which data is relevant to which business processes, and the guy would help organizing so everything data governance, and it's all about development. But at the same time, it's closer to business. So data engineers are not required to know algorithms or statistics, but still they need to code a lot. They need to work with data a lot. And we can also highlight some more specific positions like these corners in this triangle. So if we highlight this math corner, then it would be mostly an ML researcher, so a person who would study different approaches, how you can tackle actually different data science problems. It can be a bit far away from current business domain. It's not about deployment and development, so that would be a machine learning researcher, let's say, researching how you can apply transformers to your, let's say, sentiment analysis task. So for quite a while, it can be far away from deployment, but still it can be profitable. A typical analyst would know domain knowledge. So an analyst typically would just dig into the problem, build some graphs, understand the problem, talk to business a lot. So typically we wouldn't require knowing algorithms or math or coding. So it would be this top corner. And then DevOps, we're also going to discuss it today a bit. So it's the right corner. Yeah, so typical DevOps would help in deployment, in CI/CD, so this continuous integration and continuous deployment, or sometimes also known as continuous delivery. So again, it's far away from algorithms or domain knowledge. So it's just helping all the other data scientists to maintain models in production. So I would say before you actually step into data science, you'd better keep this picture in mind so that you understand all these different flavors of data science and what's closer to you. So for me personally, so I stepped into data science out of PhD. So I would say I'm still much closer to this bottom left corner, ML researcher. But my current vector of development is here towards the middle, so I'm progressing with development and have to dive a bit more into business domain. So it's good that you understand all these different subdomains of data science, and bear in mind what's closer actually to your interests. Just a small pause here to check whether the streaming is fine. So maybe somebody can confirm that it's all good sound. So we've got a thread in Open Data Science in the channel mlcourse.ai.news. So there we have some questions from you, and maybe somebody in the same thread can confirm that the sound is good. So I actually really like this simple illustration. So all the different types of data science that you can see. So still there are a lot of discussions about that. Holy wars, what's the difference between data analysts and data scientists? But this, I would say, would be a nice proxy to actually understand all the subdomains of data science. And one sec, I will take a look at myself, whether I can at least see myself in this streaming? Okay, okay, fine. So let's go on. And actually, the preparation for your first data scientist position and at the same time that today's plan would include all of this: Python, SQL, math, algorithms, and actually data structures as well, DevOps, machine learning and deep learning, pet projects, competitions, and interviews. So it's quite a lot. And I would say right away, join open data science communities, this ODS.ai. We've got all the different channels about the same things. So for Python, we've got a separate channel, lang_Python. For SQL, math, for almost for all of that. So actually, most of discussions are still in Russian because the community originates from Russia. But if you start a discussion in English, no problem at all. So in a thread, they will go on discussing that in English. So anything related to career can be actually discussed in open data science. Okay, so we start with Python. Here I need to distinguish three levels, so a basic level, medium, and advanced. As for basic level, you can just cover some online tutorials found on Code Academy, maybe DataCamp, DataQuest, or Kaggle Learn. That's a really good start. So maybe that's even enough. For a medium level, I've linked here an edX course. I think it's called Introduction to Computer Science and Programming. Or maybe something similar, so you can easily share your links as well. As for advanced level, I would question whether it's really needed for junior data scientist position. Of course, it would never hurt, but well, a lot of things wouldn't hurt. So for instance, C++, whether you really need it, I would say by default no, but depends on the position. So if you want to deal with self-driving cars, let's say, and you also pursue a junior position there, maybe there is a requirement. So check the requirements for your vacancy, but by default, well, C++ is not needed. And I would say a really advanced Python level with, well, when you study all these bindings with C++ itself, I don't think it's really needed for junior data scientists. But anyway, here I link one of the advanced courses that I know. So unfortunately, some of the resources will be in Russian. So then I would say just or similar. So Computer Science Center, based in St. Petersburg, provides a really cool course on all the nitty-gritty details in Python. But I would say for the first position, yeah, just go through Kaggle Learn tutorials or DataCamp, and then actually you can start practicing. And while practicing, while doing some real projects or side projects, you can actually learn on the go. At least that's how I jumped into Python. I didn't cover tutorials at all. I had a task at work, so I think I was 19 and had my first job, and there I actually learned Python. So that's actually a good way. As for SQL, I would say don't just study it for fun. It's no fun. It's just pure work. If you spend too much time on SQL, so anyway, if you don't practice it for a couple of years, you'd forget a lot of stuff. So actually, I've got a background in BI and business intelligence. So I dealt a lot with databases and SQL, but I've actually never practiced it too much. So my current level is honestly something a simple select with group by. So that's my current level of SQL. But well, in different projects, you might deal with different databases. Like we worked with ClickHouse, and now we work with Teradata. So if you don't need it every day, then you would forget it. So I would say, yeah, you can also pass a tutorial like Kaggle Learn, and then before an interview, you can refresh your knowledge. And the rest you can easily pick up at work. Okay, fine. So as for math, that's a more interesting question, I would say. So it's a really serious discussion how much math is needed in data science. Well, you can learn how to tune XGBoost, LightGBM, actually without really deep understanding of what gradient boosting is, what's the math behind gradient boosting. So I would recommend it to treat math as fundamental science. Well, it actually is fundamental science. So a very similar discussion is whether government shall support fundamental science, like whether we need to support physicists who are just curious to know what dark matter is. It's definitely worth investment, but it's hard to predict in what specific way it's useful. As a byproduct of fundamental research, we've got a lot of things that that are around us, like internet, all these mobile devices. These are, well, maybe questionably, but we can say that these are byproducts of fundamental research. And we have to invest into it, and it's hard to say when we will actually see any meaningful outcome. And as for data science and math, it's still the same. So I would still recommend learning math. At least it would help you understanding neural nets if you're interested in it. And well, just simply, it's a very, very beautiful domain. So when you're dealing with SQL, with setting configs and YAML files and all this actually shitty job, then you can learn math, and it's sort of raising you above all these subroutines. And well, it's maybe some philosophic Platonic ideas about this ideal world. So math is just pure knowledge. And apart from that being cool, I would say it's at least needed for you to understand neural nets. So if you deal with deep learning, so at some point you will need to understand how these algorithms work. So suppose you are doing research and you need to understand the approach that you're using. So probably it's described in a scientific paper with quite a bit of math, which you also can skip, but still to understand main ideas, for instance, how style transfer works, then there will be some math there. So it's really good to know math. It's critical for some applications like A/B testing. So some domains are really applied math. So in your day-to-day job. So if you're doing with A/B testing or similar interleaving, so deciding whether you've made an improvement to your model, that's pure math. Not pure, sorry, applied math, but still it's math in your day-to-day job. But in general, I would say it's just worth it. And so I'm here linking some resources. So if it's a single link, it's open MIT courseware, so where you can find a lot of math courses of different levels. If you already studied math and you sort of, maybe you don't need a dive into all the courses and you can quickly refresh, then I'm linking here Math for ML. So this book is going to be published soon, but for now it's a GitHub repo. And again, I can't help but sharing a resource in Russian. So one of the guys from ODS.ai actually created a list with resources, so collected within ODS. So let me try to click here. It's not clickable. Okay, let me find it. Okay, so it's in Russian, sorry for that, though a lot of resources are linked in English. So for instance, for linear algebra, Gilbert, Strang, maybe one of enthusiasts can translate it all into English, would be cool. And you see it's split into linear algebra, probability theory, statistics, and math analysis. So these are 4 basic domains that you need for to learn for your applications in ML. Maybe I would add optimization as well. And the guy, this Konstantin, so he actually asked a lot of members of ODS community, what would you recommend? And you can find a lot of links here. So really a lot. Most of them are in Russian. but still, I think it's easy to compile a list like that, maybe even in comments to this YouTube video. Okay. So you need to be careful about math. So of course it requires some fundamental education, and yeah, just realize to what extent would you would need math in your work. But of course, yeah, sometimes people would ask, so interviewers would ask math questions on interviews. So at least you need to refresh these domains. And yes, indeed, I promised to provide some examples. So from real interviews. So it's also a debatable question whether we need to ask math during interviews. I still would say yes. An interview is actually a lottery, both for a company and for a candidate. So you cannot learn everything about a company or a candidate. So during an interview, so only a trial period will actually show whether you can work together. And so still you need to introduce some bias. Yeah. So if you've got 100 candidates for 3 positions, then definitely you introduce some bias to select from these 100 people. So in my current company, I would say a huge bias is just whether you like a person. Yeah. So we have a first interview, so just a first talk. And it's mostly what type of personality it is, what background he or she has. But actually it's very, very informal. And I would say there is a team fit bias, which is really hard to define. Then, of course, we have some technical interviews and case presentation. So it's take away home assignment. But still, I would say the role of just liking a person is still very, very important. And as for me, we'd better introduce this technical bias. So we'll discuss it again with respect to these algorithms and data structures and Google-style interviews. But still, I would say it's better to introduce this math or algo bias instead of just team fit bias, if I conveyed my idea really well. So still, I think it's better to select people based on some math knowledge and yeah, algorithms skills. So a typical question that I would ask to just warm up is, yeah, let's say we've got normal distribution. So yeah, it's good to know, it's good if you can write a formula for the probability density function of a normal distribution, though I don't strictly require that. But well, so for normal distribution, it would be this exponent. So the distribution would center around mu, and well, at least it's good for you to remember that it's some exponent with a quadratic term. So if it's centered around mu, and this is x-axis, then we'll have something like x minus mu. But then it will be squared and divided by 2 sigma squared. And then we'll have some term here, which is, yeah, it's fine if you don't remember that. And we can actually, it's a constant term, so we can actually define, just designate this as A. And then the question would be that we have 2 interesting points here, a left and right one. And so if we call them point x1 and x2, so before this point x1, so to the left here, we've got a convex function. Then it changes its behavior, so now it's concave. And then again, it changes its behavior and the function becomes convex again. So you can find actually these points. So you need to take derivatives, so actually a second derivative. So it's about a math analysis, so analyzing a simple function. So it would be a warm-up exercise to actually being able to analyze a simple function, being able to differentiate. So if you go on with that, so today's talk is more, so it's less technical, and we discussed career a bit more, so I'm not going to take all these derivatives, but then you will actually find out that this left point is mu minus sigma, and this right point is mu plus sigma. And I've already skipped Python, and so as for Python, I used to ask simple coding tasks. Now I actually thought better about it. So now I don't ask candidates to code real time in real life, mostly because it checks your nervousness, your ability to struggle with stress. I think that it doesn't actually show a lot about your Python skills. Uh, so, uh, but still, at least even white coding, so whiteboard coding without actually writing any code. Still, they can ask you a simple question like, can you code a Fibonacci generator? So a Fibonacci sequence would start with 0 and 1. Well, in some definitions, it starts with 1 and 1. And then every next term is the sum of two previous terms. So then the sequence will be 1, 1, 2, 3, 2 plus 3 is 5, 3 plus 5 is 8. And then they can ask you to write a Fibonacci generator that if you pass an index n, then the generator will output Fibonacci, so nth Fibonacci element. And you can do it in different ways. So you can write a for loop. So that would be, so you can stick to iterative approach. So just for e from 0 to n minus 1, you calculate Fibonacci element, and then you output the last one. Or you can actually, you can be asked to stick to recursive approach, and then it will be a bit different. A bit more advanced level would be to analyze the behavior of this algorithm, but well, honestly, I don't ask such questions on interviews, and I was never actually asked to analyze an algorithm in an interview. But that's still what you can expect from such an interview. Fine, so let's go on. Yeah, now algorithms. And data structures. So this picture nicely illustrates all the ways you can struggle with that. So with the recursive approach. So here we have two classical courses. Those by Robert Sedgwick from, that's not Stanford or Princeton. Okay, and Tim Roughgarden, so he's from Stanford. I actually covered the course from Roughgarden. So it's really nice for you to understand basic algorithms and data structures. So for sure, these are the key elements of a lot of production systems in data science and ML field as well. But then there is a huge tendency that in many places, they actually ask you to code or to do whiteboard coding. So it's a pretty controversial topic, but still, you'd better be prepared for that, at least at some level. So there is a nice resource, LeetCode, so it's pretty famous. And so there you can practice actually coding simple tasks like that. Well, it depends. There are different levels of difficulty there. And such tasks like generating Fibonacci sequence or something else, like from my experience, I was asked to do something like calculating a median of a sequence of pairs. So we have tuples, left element and right element, and there's a medium element somewhere in between, just an average. And then we've got a sequence, so actually a stream of such tuples. And how would we calculate the overall median element in this sequence? So something like that. So you can find a lot of tasks like that on LeetCode. And actually, I've seen a lot of good reviews about InterviewBeat. So this resource also provides a lot of guidance on such tasks, and they really correlate pretty well with what is asked during interviews. Actually, it's you'd better be prepared for that. Again, you need to understand how much time you are going to devote to that. So they say if you spend 10,000 hours at any topic, you can be a real master of that. But 10,000 hours is a lot if you calculate. It's some 10 years working, well, many hours per week. So you'd better think of, you need to understand how much time you can devote to that. I would say starting with 100 tasks on lead code will definitely be beneficial, and actually taking some classic course on algorithms and data structures. And at the same time, there is a classic book, Cracking the Coding Interview. It's all about these Google-style interviews. So I still mention here that it's a controversial topic. Again, that's a question of how well it actually correlates with your skills. But remember this selection bias. I still think that such a bias is fair. So at least requiring knowledge of algorithms and data structures is better than just to decide whether we like a person or not. And of course, companies like Google, Facebook, Amazon, Uber, they can afford it. So there is this classic joke of a recruiter who's got a huge pile of interviews, of CVs. And then the recruiter needs to select a bunch of people from this pile. And he or she just pushes the top of this huge pile. So almost half of the sheets are dropped on the floor. And then the colleague asks, so what are you doing? I don't need suckers. So, of course, requiring some knowledge of algorithms is much better than any bias that we can think of. And I would say, yeah, top companies can afford that. And in general, I describe these as Google-style interviews. But there's some more to that. So I would say, of course, yeah, if I aim to work at Google, let's say, yeah, I might think about it, whether it's worth my time investment to prepare. But then, well, yeah, for such a company, of course, I would have to prepare, and of course, I would have to refresh all of that. But if it's a modest company, like something different, let's say a small online market, or let's say a small telecom operator, and then they are asking some such questions, then I would really try to challenge them. So guys, does it really correlate with the skills? So I'll tell here my personal story. So I, while working at mail.ru group, just out of interest, I visited one interview with an NLP startup. So actually, so they were doing nice job with chatbots, actually FAQ bots. But during this talk, I actually realized that I'm not going to join in them for a very simple reason, because they are mostly scattered around the world, and they are not sitting and working together. And for me, this teamwork is very important. So we can solve your simple questions much faster if you are sitting and working together. So I'm a team player. But at the same time, the interview started in a purely this Google-style manner. So actually this task of something like calculating a median in a flow or in a stream of tuples, I think honestly I failed it. So there is a simple linear algorithm to solve this task, and I came up with something quadratic, and then probably improved it to n log n, but still there is a linear algorithm for that. So actually I'm not ashamed of that. I didn't practice all of this stuff, and that's why I failed. But at the same time, I thought, well, so this does not correlate with what I'm going to do with all this NLP stuff. And so if you are being interviewed into a small company and you've got a good choice, you can actually challenge your interviewers. So why would I sit and solve, rebalance this red and black tree or something like that? So I really recommend you to have a good choice and to actually learn more about your would-be company to join. And then it's also a factor. It's also actually a good factor of whether they ask something like that, or they are more interested in your actual work and your real projects. So to summarize, I would say that you'd better be prepared for such questions. But unless it's Google, Facebook, or some other top companies, I wouldn't recommend spending really thousands of hours cracking these tasks and actually lead coding. So here, as for algorithms, apart from this simple coding like Fibonacci generator, some actual question can be I really liked one of the questions that I was asked because it's much closer to life, and it still deals with algorithms. So if we have some logs, let's say we've got some huge file, log.txt or whatever, and to simplify, we just store all the URLs visited by our customers. So let's say here we'll have facebook.com, blah, 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 google.com. And so we've got this huge list of URLs visited by customers. Of course, we'll have some customer ID, some other features, but to simplify, it's just a list of strings of URLs. And then let's say we keep track of users visiting different sites, and then probably we'd like to use this information in some recommender systems. So probably we're building a recommender system, and we would like, or maybe we are doing advertisement, and we would like to show some popular websites to our user. It can be, of course, different. So maybe a customer is clicking on different ads, and then we would like to recommend other ads. But let's simplify it to a purely algorithmic question. So how do we select top K elements? So let's say we somehow calculated frequencies. So we end up with a dictionary that Facebook.com was visited that many times, something like that. Then let's say Google and some other frequency. Maybe it's vice versa, but still. Okay, so let's say we've ended up with a dictionary of all frequencies, but still the dictionary is huge. So let's say there will be capital N elements here, and N is about 10 to the power of how much? Let's say 7. And we need to select top K elements to actually show the most frequent items. So these items being either documents or URLs. So I also need to refresh actually the task to actually show a nice elegant solution. I'm not doing because this is not a really technical talk, but it turns out, so it's a pretty popular task, and it heavily depends on this K. So this K might be, let's say, something small like 10, so select top 10 elements, or this K might be 10 to the power 4, or maybe something in the middle like 100. So it turns out there are different ways to attack this problem. So you can apply minimal heap here, or you can actually adapt quicksort to perform this task. So if you remember in quicksort, we select a pivot element, and then we compare all the elements with this pivot, and we select those branches of one branch of elements which are all lower than this pivot. So actually with this technique, we can actually adapt quicksort to select top elements. So just sticking to one branch. So it's actually a nice task. So it's discussed definitely on Stack Overflow, I think on LeetCode as well. So we can take a look. But it's good that it's actually real ML engineers sometimes need to adapt their algorithms and data structures to the data that they have. So probably if you have really a lot of information like that, maybe you don't just plug it into Hadoop or Spark. So you just have too much data, and you need to actually adapt your algorithms. And it actually helps to know algorithms for certain tasks like that. And that's why sometimes they actually ask it on interviews. Okay, fine. So then we go to DevOps. Mostly you will learn this at work. One sec. Yeah, I needed to let this little bastard out. Okay, so at least you'd better learn Git. So Git is in principle just a way for you to collaborate with other people to work together on the same code. And it's a bit annoying when a person who you are going to collaborate with cannot merge branches and so on. So it's just a way to collaborate. You'd better take a look at this in this way. So being able to collaborate, to work on code together, you need to know Git. And here I link a nice resource for that. Try Git. So a simple interactive tutorial to begin with. So that will do. Anyway, while working on a real project, you'll have to fix some conflicts, to merge branches. You'd better not learn it in advance. You'll just learn it in progress. As for me, some maybe 10 years ago, I covered a course on Git. And that was actually a mistake. I wouldn't recommend you to just learn all the beautiful concepts around Git and GitHub, all these graphs of changes. That's just an extra information, and if you don't practice it, you just easily forget what you learned. So at the same time, it's good to show during an interview that you understand how models are deployed. So you'd better be familiar with Docker and Kubernetes. I would say it's mostly about ML engineering, so it depends heavily on the position. So somewhere you'll be just asked to know how sklearn works, and they will ask you maybe some math questions, but nothing about DevOps. So it depends on the position, so take a look at the requirements. And yes, it's mostly about ML engineering, not what we typically call by data science. So actually, background in software engineering will definitely help. So it's actually much better for most of the companies to take a software engineer and ask him to learn all this math, ML, algos, and all this cool stuff. It's typically much better than to take a PhD guy and then wait while a PhD guy would learn all this stuff, coding and DevOps. Well, not coding, but developing. Yeah, so it's quite different things, like being able to collaborate with other people in a project. So background is in software engineering. I see it's really often appreciated. Again, depends on the position. But I would say you can also learn it at work. So it's better to show that you're a bit familiar, and we'll further discuss it in a pet project. You can actually practice these things. But now I see that all this stuff gains more and more importance. Like it's required from data scientists to understand how production actually works. So data scientists, so those guys who actually model something, they would collaborate with ML engineers and data engineers, and this collaboration is going to go much smoother if actually data scientists also understand how it all works under the hood. Because in the end, you typically make a product, so your model is not just a Jupyter notebook; it's a product, and you'll have to maintain this product in production. And here goes all of the DevOps stuff. So you'd better be prepared to at least know something about Docker, Kubernetes, and GitHub, so beforehand. And then we actually go to machine learning and deep learning. So mlcourse.ai covers really well all the basic ML stuff. So Andrew NG's course, relevant Coursera specializations are of course really good as well. Yeah, we typically tend to compare. So people ask me, how is mlcourse.ai better than Andrew NG's course? I would say I started myself with Andrew NG's course, and it's just fabulous. So like Andrew NG is really charismatic, and the way he conveys material is almost perfect, I would say. So some of the parts in that course are just, I would say, eternal. So they will never be outdated. But as for practical part, there you've got this Octave language. It's open source variant of MATLAB. And well, as for practice, mlcourse.ai would give you much more. So it's we've got several Kaggle competitions and a lot of practical assignments and all the up-to-date libraries. So it's much more practical. But I can't help recommending Andrew NG's course as well, because he's just very, very good at conveying material, and he just explains material really well. So as for deep learning, that can be in the next step after basic machine learning is covered. I would say two best courses here are Computer Science 231N by Stanford and fast.ai. They actually have different approaches. So computer science, so this CS231N is bottom-up. So you start with actually implementing neural nets. So you actually start with simpler algorithms like KNN or SVM, so applied to images. And then you actually, on the go, the complexity increases and you end up with these pictures, which I'll comment now. So with implementing really cool stuff. But fast.ai actually is about top-down approach. So with a couple of lines, you train a state-of-the-art model, and then you actually get to understanding how it all works. So these are two good options. I actually prefer Stanford's course. So it's called Convolutional Neural Networks in image recognition, I think. Yeah, so it's basically on computer vision, but it actually offers a very broad, nice overview of what actually neural networks are in general. And we actually offer to pass this course together within ODS.ai. It's mostly your work on your own, because the hardest part is that actually all of the materials are already shared. Let me actually try to click these links. Okay, anyway. So you can easily find answers to all these solutions. So you can do it so easily that actually I've just created my own repo with all of that. Convolutional neural networks for visual recognition. Yeah, so we offer some playground, so a channel in ODS.ai, and but mostly you work on your own. So assignments are really tough and challenging. So you start with NumPy, so pure Python plus NumPy, implementing basic algorithms. Then the same for convolutional networks. So this part is really tedious. And then assignment 3 contains several parts, all these cool applications. We provide you some approximate schedule, but still you need to understand that, yeah, you can discuss something with other folks, but it's mostly your work on your own. And there I don't provide a lot of guidance. Yeah, I see some problems with connection. Yeah, hopefully now it's fine. Right, okay. But as a teaser, you see these two small pictures. So these are approaches that I actually implemented myself within this course, CS231N. So left one is style transfer, when you take a base picture and then you take a style picture, and then you apply your style to an actual photo and get something new. And that's actually, in general, it's math. That's where math is needed to understand how it works, what losses do you define to actually make it work. And the second example is generating these strange images. So it's actually, we start from a random image, so just random pixels, and then we can actually modify this, this image with a neural net, maximizing the probability that it will be classified as a gorilla by a neural network. And then you end up with some pieces of gorilla and this really strange image, and it highly resembles a Deep Dream application, and you can actually build it on your own. So after ML, this deep learning will be definitely a nice next step, but also depends on your career expectations. Maybe you would better develop as a DevOps guy. Then, well, it's up to you to wait to understand how much time you can actually spend on such cool topics like deep learning. Still, I would say, again, just like math, it's just cool. It's just cool to understand what deep learning is capable of, how it all works under the hood. So to some degree, it's good to for all of you to scratch the surface of all of that. Here you actually need to be careful because these courses are pretty demanding. So again, it's up to you whether you are really going to dive into deep learning. So as for interview questions, so here as for basic ML, I would ask something like basics of logistic regression, so how it's formalized, what's the math under the hood, and yeah, something similar. Or if the guy is describing real projects, a typical question to ask is how did you validate your model? How did you perform cross-validation? So something like that. Then pet projects. So in general, these were several steps like Python, SQL, DevOps, and programming algos. And then when basic ML is covered, then you can simultaneously do competitions and pet projects. So pet projects are really cool because it's a lot of freedom, so you can actually choose anything. So here I show an example, this crypto fear and greed index. So you can actually fetch some, let's say, news on Bitcoin, and then you can label some of them and build a sentiment indicator like this one. So whether news are in general negative, neutral, or positive about Bitcoins. Well, maybe you'll need to figure it out how you actually label your data. Do you do it on your own or with Mechanical Turk? Whether you are going to spend money on that. And there's actually a lot to learn yourself. Like you can actually show that you understand something about this development and operations, this DevOps stuff. You can practice that in your own pet project. So if you really would like to learn that, so there are a lot of questions. So how would you deploy this model? So suppose you trained this sentiment model in a Jupyter notebook. Let's say it's just logistic regression with TF-IDF transformation. And then you pickle this file. But then the question is, how would you actually serve this model? So you can stop here and just show a Jupyter notebook, but it's up to you. Yeah, you can build a really nice pipeline with continuous integration and continuous development. So you can have tests to your model, make sure that it doesn't fail. You can Dockerize your application and deploy it with Kubernetes or something similar. Here you can actually stand out with the skills that you acquired, and it's actually a good thing to add to your CV. And I only wanted to mention here as well that some frameworks developed at ODS.ai, like Catalyst or Albumentations, they also started as pet projects. So Catalyst is a deep learning framework which mainly focuses on reproducible research. So all the things about logging, tracking, and making all the stuff reproducible just by hitting the button. So Catalyst also implements different state-of-the-art techniques from deep learning, similar to fast AI. Yeah? So what all the hacks and techniques that you read in papers, like different learning rate schedules or optimization algorithms. So Catalyst guys actually try to implement it in their framework as well. Albumentations are about computer vision. So actually, it's they offer a lot of different augmentations to images. Actually, in computer vision, you can generate much more valid data than you have with different augmentations. The simplest ones are taking an image and flipping it, rotating it a bit, or cropping. That's how you actually generate much more data than you had. So if you have this cat, you can actually rotate it around vertical axis, and then this will be a valid cat as well. And then you can increase your training set size 100-fold, and then you will train a better model. So a lot of state-of-the-art augmentations are actually implemented in this library, and I would say it also started as a pet project within open data science community. And we have a separate channel for that, where you can pick up an idea, or you can take a good idea from your colleagues and actually work together on that. So these pet projects and competitions, they can go in parallel. So I would say you would better first do all the previous steps, so up to basic ML and probably deep learning as well. And then Kaggle, so in general, competitions and pet projects in parallel, whatever you prefer. So again, one huge controversial topic. So to what extent you'd better do Kaggle or similar competitions? It's really cool when you enter a new domain. Like I entered NLP, and you can learn a lot on Kaggle. I really like Kaggle notebooks where people share ideas actually in code. So if you are up to diving into computer vision, let's say, or NLP or time series, then Kaggle is definitely a very good platform. So you really learn a lot, and mostly by participating in a competition. At the same time, I would recommend you to be really careful about this gamification part. So all these medals, all these rankings, they actually motivate you. That's good, but there is a downside as well here. So in this picture to the right, I'm showing some screenshot from Mercedes-Benz competition, and the topic is called like outlier number 3977 is discovered. That's an example how people spend too much time. I would actually say they waste a lot of time on Kaggle just because of this gamification. So in that competition, we had a lot of outliers. So the data set was pretty dirty. And well, there was a big challenge on how you actually perform validation. So if you think about it, with a lot of outliers, the metric there was not meaningful at all. So if you just take something simple like mean squared error, then in case of in case of huge outliers, your metric would be affected, and you will be actually predicting only. So your metric will reflect the way how good you can actually predict outliers. Well, in the end, it turned out that there was a huge shakeup. The test set distribution was pretty different. Outliers were much different. But then people did a shitload of work just finding these outliers hand by hand, creating some curated lists of outliers. Well, if you think about it, it's just wasting time. Yeah, cleaning some data. So a lot of things done on Kaggle is just wasting time. So you need to be really careful about that. So Kaggle can learn you a lot of things, but you need to actually find meaningful signal in all of the things that happen on Kaggle. To contrast that, I'm showing one of the competitions where I participated. It's an NLP. It's on pronoun resolution. Like if you have a phrase like John entered the room and saw Julia. So she was very nice talking to Mary, and she looked, I don't know, perfect. Then you've got a pronoun, her, and you need to actually understand to what entity, to what actor it actually relates. So this is pronoun resolution, and Google organized actually a research competition in NLP to actually make all these different systems work for pronoun resolution. And there people started creating different architectures, and one of the guys has just showed how BERT can be applied there. So there was a dramatic increase in quality. So log loss dropped on public leaderboard in general from something like from 90 or maybe 80 up to 53. But in general, it was a very nice competition. So maybe I'm biased here. I spent some time doing my PhD, and of course I like research. But at the same time, in this competition, we all learned that all these cool transformers, including BERT, can actually be successfully applied, and they can actually beat handcraft engineered features, some linguistic features. So there was a lot to learn in a competition like that. So just be careful with Kaggle. So definitely it's good for your CV, but bear this gamification part in mind. So don't waste your time just to grab medals in every competition. Be careful with that. And I've seen people writing in their CVs something like, I participated in blah blah in this competition, well, just don't write that. Yeah. So if you ended up on the 2,348th place in a competition, there's nothing to brag about. So just instead, I would recommend if you really did well and gained a lot in a competition, summarize it. So you can describe it as a project on LinkedIn. Just present it as a project. Be ready to discuss it during an interview. Summarize what you actually learned in the competition, like in this case with gender pronoun resolution. So like we all learned how to apply BERT for this model. It's actually much better than just writing that I am a competitor or from time to time, blah blah. I do compete. Better treat competitions as projects, and you need to understand what you actually learned in the end of a competition, instead of just grabbing some, I don't know, random bronze or maybe silver medal. Still, I would recommend Kaggle, but keep in mind everything discussed here. So now, finally, interviews. So with all these preparation steps up to basic ML, then you are doing some Kaggle and pet projects to actually make your CV stand out, to gain new experience. And then just go and practice with interviews. So I don't recommend sitting and studying for a year or for 2 years. It's not gonna work. Practice interviews. So you'd better keep getting feedback. So it's nicely summarized here. Try, fail, learn, iterate. So you are getting feedback. You understand how it all works. What questions do they ask during interviews? And you need to be prepared to fail. So learn to fail if needed. It's still a good experience. I also failed, of course, with Google interviews. With Yandex interviews, I did fail once. That one with NLP startup, I would say I also failed with algorithms. So still for you, it's a feedback where you need to focus on, what you need to pay attention to. And it's a very, very nice feedback. And well, if you fail with such huge companies like Google, Facebook, and others, well, you make some conclusions, but don't take it too personally. You need to understand that there is a huge choice, and they just preferred probably somebody who is really cool, who fits their position. And an important part is not to conclude that there is something wrong about you, that you cannot do something. You definitely can do. You need to learn from these failures and adapt your preparation schedule and so on. And so then you keep trying and gaining experience. And one more important part about interviews is this nervousness, and ability to struggle with stress. The more interviews you practice, the better. So the more calm it's for you, the more confident you look like. And it's also very important because if you're not ready for that, so if you sit for a year or year and a half and practicing all these things that we discussed, but not practicing interviews, then you can be just nervous and you can fail with simple things like writing a Fibonacci generator just because you didn't practice interviews. So here at this step, I can say that you are going to follow some steps and definitely succeed. So I'm not providing you a certain recipe how you would go here. You just practice interviews, and at some point you will succeed, definitely. At least that's how it works for almost everybody that I know. So didn't write it here, but at this point I will also add networking. So you socialize, you visit meetups, so ODS.ai is also a very good way to socialize. And don't hesitate to ask somebody to refer you. So in many companies, a referral system works pretty well. So if you have something to show, like Kaggle competitions or pet projects, at the same time, while interviewing, you can ask your buddy to refer yourself in a company. If you have something to show, typically they won't refuse. So they would indeed refer you. And then in a company, if you are looking for some candidates, of course you would pay attention to those personal recommendations by your colleagues. So typically that would mean that, well, you are going to consider a nice guy. So here you, again, interviewing, it's sort of sport. If you train a lot, if you practice, then you would be better just at interviewing. And at some point you will actually succeed. So there's also a huge topic of how you can actually, what are the right questions to ask during an interview. I think we can have a nice discussion maybe in YouTube comments to this video in mlcourse.ai. So that would be some 1 hour more to spend discussing all of that. So I think for now we stop here. And yeah, welcome to discussions in YouTube comments and in ODS. And in general, in ODS.ai, in this Slack, we've got a channel called Career, and they discuss all of these things. So here I've provided my view, but of course there are some, well, formally 30,000 or something like that, 30,000 participants, members of this ODS.ai community. The core itself is active members, maybe some 2,000, I guess, but still there are a lot of nice ideas there in the channel called Career, just Career. Well, mostly in Russian, but still you can ask a question in English. They will describe a lot of things that we just discussed and maybe providing some more, some different views on that. That was it. So it looks like it's a long path to follow. So here I'll get back to this one of the first slides. Yeah, so covering all of that looks like a long way to go. So it's also about your time management. So for sure, if you're working, let's say, as a developer and you've got family and kids, it's really hard time to actually follow this path, and it's about your time management. So I'm pretty often asked, how would you switch to data science if you have a position X in a company Y and you don't have a lot of time? So here I would say pet projects is a really nice way to stand out. And actually, let's say you are working as a developer, you can actually find some more projects within your company. So you can gradually switch to data science within your company, just taking new projects. That can also work. So of course, the hardest question here is how much you need to sacrifice in terms of salary if you switch to data science. Then of course, yeah, if you're around, well, I don't want to express ageism here, yeah, but if you're experienced, if you've got a job which occupies a lot of your time, if you've got family and kids, then of course it's really hard to switch to 70% of your salary. So then the gradual way would be to do pet projects on the side, or real projects within your company. So the last thing that I just wanted to say is that, well, yeah, don't waste all of your time on that. Well, it's not wasting, of course, it's spending time. But well, after such a lecture, you might think that, well, now I need to spend all of my time, all weekends, studying all of that. So first of all, don't dive too deep into any of these topics, like studying C++ or really advanced Python. So beware that you need to actually reach some level, but not more. Still, I would say that you at least do sports, so don't sacrifice that. So if you think that, whoa, now I'm sitting from Saturday morning to Sunday evening doing all this lead coding and all math, no, that's not a correct answer, not the right choice to do. You still need to do sports. So sports are really important to actually keep energy and retain your enthusiasm. I think many people underestimate that. Yeah. So you think that you just need to follow this path, doing X and Y and Z, but then you need energy for all of that. Yeah. And so, of course, you need not sacrifice sleep and sport. So it's really, really important. I think, well, I would better provide here some links to actual research, but I think we can find some, and it's just well known that sports are actually really good at keeping your head fresh and just maintaining this enthusiasm to go on with all of this stuff. Okay, so that was it. Good luck, and yeah, let's go on with follow-up discussions.